Alright, so here we are. We're ready to start tutorial on how to align randomly generated blocks. And what this is actually going to work with is an alignment. You're going to generate each of these prefabs procedurally in a grid pattern. It's going to end up looking something like this. And each of those is the script we're going to be working on. Is one of those is going to generate a aligned 3 more blocks, 1, 2, and 3 in that area, and it will align them properly so that we have a little square shape for them. I went and go ahead and put down a bunch of prefabs here, all the pre-made color. The prefabs here don't have a script on them. This is our completed script, and I'm going to be showing you how to put that together real quick. So let's go ahead and get started. So, of course, first, we can actually get rid of void update. We're not going to be using that at all. Everything's going to be done on instantiation. Once the object enters our game world, it'll immediately go and create the next connected block. So first, we're going to want some public transform variables. We'll call these block 1, block 2, and block 3. Those will store our reference blocks, so we'll have them red, green, and blue prefabs that we'll be calling to spawn. But ideally, we'd want to put this into array. We could have hundreds of them and use a random number to determine where in that array we're going to be looking for them. But that's something a little more advanced we'll get into later. Next, we're going to need the actual transform variable that we're going to be instantiating, and this is going to become equal to one of our 3 stored values. In the case of an array, you'd call one of the indexes on the array, and then you'd call that equal to this. You don't even need to necessarily, but it makes it a little easier for our logic, so we'll call that block final. Next, we're going to need a I'm sorry, that's not even public. We can make that private. Next, we're going to go ahead and need a private int variable, and that int is going to be a random number, and that's going to be a random number generation. Again, for an array, this would be our index, but in this case, we're just going to select 1, 2, or 3. And that's about it, actually. So, for starters, we're going to want to make sure we're going to be checking. This is all based off of the parent object's properties, so their position and rotation. And so the first thing we want to check is if it's rotated beyond 180 degrees. If it's rotated beyond 180 degrees, it means we stop. We don't want to generate anymore. That would be the 4th block in this rotation. So we'll do if transform dot. We could do rotation. Easy enough to check. Checking along the y-axis. We could check that, but rotation returns a variable, a value between 0 and 1. It's a decimal number, and we don't want that because it's a pain in the butt. Instead, we're going to use Euler angles, which returns an actual degree value, and which makes these calculations a lot easier. And so we're going to ask to make sure that it is less than or equal to 181 degrees, and if it is, we'll go ahead and continue and finish our instantiation here. So next, we're going to go ahead and call our rand function. So rand will be equal to random dot range, and range returns a integer value inclusive between the left variable entered, so we're going to go between 0 and 3, and that will return a value of 0, 1, or 2. So we'll go create a head series of if statements. Normally, we wouldn't need this. We just use rand as the index on an array, but because we're not using array, we're going to go ahead and use some if statements real quick. And equals 0. We'll go ahead and set block final equal to block 1. Actually, we can tighten that up real quick. We'll go ahead and create 3 more of those, 1 for each block. So else if rand is equal to 1, we'll make block final equal to block 2. Else it's going to be equal to 2. So we don't need to check. We can just say else block final equals block 3. And then we're going to want another series of if statements, and those if statements are going to be to actually generate our blocks. So it's going to be a little bigger than this. So the first one we're going to ask is if transform angles y equals 0, we're going to go ahead and instantiate our block final. So that's going to be the transform we're instantiating. Then we need our position, so we're going to go ahead and do transform position. We don't want to spawn it exactly on top of the one we're using, so we're going to go ahead and add a new vector 3 to that to get the altered position. We're going to spawn it next to it. So that we want to show that it's going to show up a value over, or a block over. So in this space, right? So right here, see our z value is changing. So we want to spawn it next to that. So we're going to want to increase that by 10 on the z value. So we're going to add 0 to the x, 0 to the y, and 10 float to the z. And that should position it right next to this. And last, we want to add the rotation. Let me just double check so we wrote that. Yep. Quaternion, yeah, it's a pain in the butt, right? But okay. So we're going to go ahead and make the rotation quaternion dot Euler. We're going to create a quaternion Euler number, which refers to our rotation, equal to our transform dot leave Euler angles again. Yep, Euler angles. And we're going to add to that another new vector 3. And this is going to be the same one every time because we are rotating it on the y-axis 90 degrees with every instantiation. And that should do it. Except we gotta close our instantiate there. And that should do it for that. And so we'll go ahead and take that snippet of code, and we can throw that in here. And we'll ask for our Euler angles again. But this time we want to ask if it has been rotated 90 degrees. 90 degrees on the y-axis. And we're going to want to go ahead and rotate it 90 degrees again for the next one after that. But this time we're not going to move it 10 degrees on the z-axis. We are in fact going to move it because the next one is going to be in this section here on the right side. We're going to move it instead on the x-axis, and we want to move it up 10 units on the x-axis. So we will add 10 degrees note to the x-axis. Then we do that again one last time for our last statement here for the fourth one, which will be down here, and because the parent one for that is going to be on the right here, we're going to move that backwards on the z-axis this direction. So that's going to be subtracting 10 on the z-axis. So instead of adding 10 on the z-axis here, we'll instead subtract that. And that should be it for our code. So we go to our prefabs, and we'll take our code and we'll go ahead and add it in to each of those. And that'll be that. So because we're not using an array, we do have to go ahead and assign block 1, block 2, and block 3 to these here. So we'll go ahead and assign red to 1, green to 2, blue to 3. We have to do that for each one. It's a little tedious, but with the array it would be easier. But we're not going to worry about that right now. It's a little more work than we want to bother with. Trust me. But that'll be the next step. But now we've got those assigned, let's check it out. We'll go to our game view and we press play, and it should, yep, generates a random corner for each of these right there. Gorgeous, isn't it? So what we can do is, instead of these little color blocks I've been creating here, we can put in the corner of a street block, or sections of terrain that line up with each other, just to make sure that they align correctly. And so when you create them, you just need to create this corner, and then that corner will spawn the rest of these three as you generate them outwardly in a grid pattern. And that will create some really nice looking terrain. There's some other tricks for helping that change over time in a really nice natural feel. And you can add other scripts to add trees in random spots or cars and things, and really add a truly natural generation to it. But this is the good first step. So I hope you learned something today. Good luck.